All right, welcome back to Calculus 2. So we are going to be looking at the series of n plus n plus 5 over n cubed plus 1. We're going to show that this converges or diverges by use of comparison test. So the first thing I'm going to do is say, this is going to be a little bit on the longer side of things. I'm just going to do it because you want to remove any possibility of like, are you sure you know? Like, yeah, we're sure. And like, how do you know you're sure? And we're just going to kind of take it slowly and say that we're going to kind of do this piece one thing at a time. Okay. So we're going to be able to say that n plus 5 over n cubed plus 1 is going to be equal to n over n cubed plus 1 plus 5 over n cubed plus 1. One of those things I'm going to note is that if you have the sum of two convergent series, that also converges. So we can say the sum of two convergent series converges. Okay, so we can go ahead and say that. I'm sure there's a theorem in your book that goes through that, and I should really find that out, but we can pretty much note that this is going to be the idea. Okay, that's series are very difficult to deal with, but we're gonna go off and say this. Okay. So what I want to do is I want to compare n over n cubed plus 1 to 1 over n squared. Okay. Because that's kind of what happens here. And I want to say that 5 over n cubed plus 1, I want to convert it. I want to compare it to 1 over n cubed. Okay. Now, if both of these are smaller than my 1 over n, this one will converge by the p series. Okay. The p series test rather. P-test. This one converges by p-test. All I need to show is that this series is smaller than that series, and then this 5 over n cubed plus 1 is smaller than n cubed. Okay, so that's what we're going to be doing about this thing. Okay, so how we're actually, it doesn't, we don't really need this. If you had a 5 in here, this still converges by p-test. So this one, I think this one is well, it's not obvious because we still have to know that n cubed plus 1 is smaller than 5 over n cubed. So let's go ahead and do that one first. So we could say, is 5 over n cubed plus 1 less than n cubed plus 1? Okay, is this true? Okay, so the first thing we're going to do is I'm going to say that I think we could say without proof that n cubed plus 1 is greater than n cubed. We could even multiply both of these guys by 5. Okay, so we have 5 n cubed plus 1 is greater than 5 n cubed. I think that's a fair thing to say. So what we're going to do is we're going to divide both sides by n cubed times n cubed plus 1. Again, for n is greater than 1, which is what we have, we're dividing by positive numbers, so we're not changing the direction of our inequality. Okay, n cubed plus 1. Now, what's going to happen here is that there's going to be certain pieces that are going to cancel. So we have this is 5 over n cubed plus 1. Keep the inequality where it is. These are going to cancel here. So this pair is going to cancel with that. So 5n cubed is greater than 5 over n cubed plus 1. Or equivalently, right, because it doesn't really matter which side you write this on, and 5 over n cubed plus 1 is less than 5 over n cubed. Okay, we're pretty much going to do the same thing with the other piece here. Okay, so we can just kind of say, well, what about the other part, right? Is n over n cubed, n cubed plus 1 smaller than 1 over n cubed. So is n over n cubed plus 1 smaller than 1 over n squared? Okay, and we're pretty much going to do the same thing. We're going to say, well, I think that we could say that n cubed, let's see if we could do this one. How do I want to, okay, we're going to go ahead and do the same thing. So we could say that n cubed plus 1 is greater than n squared. Okay, that's, I think, again, you can pretty much say this without proof. I think that's, a, yeah, for n greater than or equal to 1, I think that's going to be true by on its face. You don't have to go through and actually prove that. Okay, and what I'm going to do is I'm just going to divide again by a positive number, n cubed plus 1, and then 1 over n squared plus n cubed plus 1. So I'm just dividing by the same thing that we just did before that. Okay, so the n's going to cancel, so we're going to go ahead and see these guys cancel. So we have 1 over n squared is greater than 1 over n cubed plus 1. So again, we could say that 1 over n cubed plus 1 is less than 1 over n squared. Okay, so we can pretty much say that. Okay. Now what I'm gonna do is I'm just gonna multiply. I'm just gonna examine this little piece right here. Okay, we're just gonna take a look at that. So we have n over n cubed plus 1, which kind of reduces to, if we multiply 1 over n, 1 over n, we're going to end up with 1 over n squared plus 1. So we go ahead and say that this is going to go ahead and be smaller than 1 over n squared. So again, since n squared converges by p-test, we can say that n over n cubed plus 1 converges with comparison. Converges by comparison. Okay. Now, you might say, well, it seemed like an awful long way to go out of your way to prove this stuff when to me, it felt like it was fairly obvious. And like, it kind of does, which is kind of nice. But the whole thing about it giving you a test question like this is to make you go through like all the little bells and whistles to make sure that you've got this. And what this prepares you for later is like, you're going to say something when you have your actual jobs. You're going to say, I'm going to make this claim. And your supervisor or your coworkers are going to ask you, like, well, how do you know? Can you prove it? Can you actually show it goes from this point to this point to this point? Or you made an assumption. Like, how are you sure you can make that assumption? So it kind of goes through and trains you to like, okay, let's just double check and make sure that can I actually prove this? And go through all the different steps to say that this is going to be proved. Okay. Some of you are going to have bosses, but you're going to say, just give me the answer. I don't care. That's fine. Some of you are going to have supervisors like, walk me through your process. And then everything you do, they're going to like, well, how do you know that? And you're going to have to go through and prove every little piece on there to show your supervisor that you actually went through and did this to make sure it actually works the way you said it works. Okay, so all of this is a good test for like, how do when you have your first job and you have a thing and you're like, walk me through your process. And then they're going to say, what assumptions did you make? How did you make them? Can you prove to me that those were good assumptions? That's what this kind of thinking prepares you to do. Okay, so don't look at it like, I'll never need to do this. Like this problem? No, you will never need to do this. But someday you're going to be working on something and you're like, hey, we checked this. I'm like, did you? How did you check it? Walk me through your process on how you check this. So it's a good thing to learn how to think this way so that you can actually make sure that if you need to do it on the job, you've done it before. And that's what this is all going to. So we could say, okay, what was it? 5. I'll go ahead and double check myself. So we have n plus 5 over n cubed plus 1. So just to put the final statement on it, n plus 5 over n cubed plus 1 converges, okay, with comparison to 1 over n cubed plus, or n 1 over, let's do it that way, n over n squared, okay, which converges by p-test. Okay. As far as what the convergence, when you're doing the comparison test, what I'm looking for is, did you check to make sure that you have one side less than the other side so that you claim that one side converges if the side you're looking for converges, or the side you're looking for is smaller than the thing that converges, then it converges. That's what I'm looking for as far as did you get the right answer? Okay. So I'll say thank you very much for watching my video. We'll see you in the next one. Take care until then.